Greetings everybody, and welcome to Euclid's proposition number 9. Basically what proposition number 9 tells us is that if we are given any angle, then it's possible to bisect that angle using our tools of compass and straightedge. So let's look at the demonstration for why this is going to be true. So let's suppose that we're given our angle ABC. Now, what we want to do is to just choose any point D on our line segment AB. Now, what we want to do is to draw a circle, and we can draw a circle centered at B and passing through D. One of our postulates tells us that we're able to do that. And what this in turn gives us is a new point E on our ray BC where our circle intersects our ray. So at this point we have our new point E and we don't need our circle anymore. Now, because our point D and E came from the same circle, what we know from our definition of a circle is that our line segment BE is going to be congruent to our line segment BD. Now we want to take a look at our line segment DE. If we go back to proposition 1, we know that from this line segment, or from any line segment, we're able to construct an equilateral triangle. And if we go back and look at that video for how that worked, we know that we draw a circle centered at D and passing a circle centered at E and passing through D. And then we also did a circle centered at E and passing through D. And what this in turn gave us was our new point, a point of intersection, say F, with those two circles. And what this gave us then is our equilateral triangle E, EF, and D. And so with our new point F, we don't need our first circle and we don't need our second circle any longer. And at this point, something else that we don't really need is our line segment ED. Okay. But what we do have is from this new point, we can draw our ray BF. Now we're almost there in showing that this really gives us our bisection. And so we need to just take a look and see, well, why now are these two angles, FBE and DBF, why are they going to be congruent? Well, as we can see, our line segment BE is going to be congruent to our line segment BD. We have from our equilateral triangle that our line segment EF is going to be congruent to our line segment DF. And then finally, our line segment BF is just naturally going to be congruent to itself. And what this gives us is two triangles where we have a congruence between all three sides. And so by our proposition 8, our triangle BEF and BDF are going to be congruent by side-side-side congruence. And so as our final step, because these triangles are going to be congruent, it means in particular that our angle between sides 1 and 3 in both triangles will also be congruent. Hence, our angle FBE is going to be congruent to our angle DBF. And that was exactly what we wished to demonstrate. I hope you guys have enjoyed this, and I will see you guys in the next video. Take care.